अच्छा लग रहा है ये,
है ना? भैया इनके लिए तो 6-7 इंच वाली हील दिखा दो।
ठीक है।
हाँ बेटा बोल।
माँ,
हाँ
मैंने टीचिंग एग्जाम क्लियर कर लिया।
सच? भैया
हाँ जी।
फ्लैट सी दिखाइए।
क्यों, क्या हुआ? कद बढ़ाने के लिए अब लटकना शुरू करोगी दिन रात 24/7?
बेटी ने अड्डा 24/7 ज्वाइन किया और टीचिंग एग्जाम क्लियर किया। और बच्चे जब तरक्की करते हैं ना तो माँ बाप का कद अपने आप बढ़ जाता है।
अड्डा 24/7 की एक्सपर्ट एंड एक्सपीरियंस्ड फैकल्टी और क्वालिटी एजुकेशन से आप तैयार होते हैं बैंकिंग, टीचिंग, एसएससी जैसे अनेक कम्पिटिटिव एग्जाम्स को क्लियर करने के लिए और एक अच्छा करियर बनाने के लिए।
अड्डा 24/7 जॉब है तो रॉब है।
नाइस ना?
Friends, welcome to Adda 24/7. Today's topic of discussion is important and the difficult part. Difficult part in the sense because we'll be dealing with probabilities. Probabilities, 3 types of probabilities are there in your exam, and that all the 3 I'll be giving you via types of probabilities in theory, and we'll be solving the important case studies over here. So watch the video till end. Also in this champion series we are going on with complete CIB revision, ABM and BFM. So follow the complete series as such from start to end. Don't miss any lecture. Before that, download Adda 24/7 app on your mobile. Also join Officers Adda247 YouTube channel. On this app you'll get the study material, video lectures, tests, notes, everything required for CIB at one go. So don't go here and there, okay? Also importantly, see this batch has already started. June 6th today, right? So yesterday, in fact, not today. Yeah, so June 6th this batch has started, selection batch. It's a short term crash course. Yesterday if you might have missed, don't worry, you'll get the recorded videos, but don't miss it for future. In 12 days we are covering ABM, 12 days we are covering BFM, all the topics, numericals, everything. So why do you wait? Okay, join fast. Okay, I'll come to this later. Okay, probability distribution, 3 types of probabilities are there in your exam. Okay, and as per our schedule we'll be first studying the theory part, but theory part is not boring. Understand this. Theory means we feel, oh theory, no, not again. No, but it's not that. This theory is as interesting and as difficult as problems. Okay, so Bernoulli distribution, we have 3 distributions basically. One is Bernoulli, second is binomial, and third is Poisson. These 3 are there in your CIB syllabus. So Bernoulli distribution, Bernoulli is a discrete probability distribution where the Bernoulli random variable can have only 0 or 1 as outcome. Means what? Bernoulli distribution can be applied where you will have only 2 results, either 0 or 1. 0 or 1 means what? It's not actually number 0 and 0 1. No, it's not that. Where you will have only 2 outcomes, either true or false. You'll say, what is this then? How can I have only 2 outcomes? Yes, we can have 2 outcomes. Like if I flip a coin, okay, either I'll get head or tail. So only 2 outcomes. If I give an exam, I'll have only 2 outcomes, pass or fail, right? Now you'll say there are so many cases where more than 2 outcomes are there. Yes, there are many cases, but we divide it into these all cases such that I get this X or not X. For example, suppose if I roll a die. Die means what? That Ludo we play, Ludo game, right? That die 6 faces. So you'll say there are 6 outcomes then. So that can be converted into Bernoulli. How? Means if I say either I get 1 at the head or not 1 at the head. So when I say not 1, it means I can get 2, 3, 4, 5, 6, up to 6 I can get. So anything which is not 1 is not required, means failure, and 1 at the head means which is at the top, right? So what have I done? All the 6 outcomes I have converted into 2. So remember, Bernoulli should always have only 2 outcomes, 0 or 1, true or false, yes or no. Okay, there is nothing in between. P is the probability of success and 1 minus P is the probability of failure. We call it Q also. Some books call this 1 minus P as Q. Okay, so P is success and Q is failure. Okay, so how is probability of Bernoulli given? Either P or Q. But remember, in Bernoulli there is only one trial, means one time I'll roll the dice, one time I'll flip the coin, okay, only once. So that is Bernoulli distribution. Got this point everyone? Type yes if you have understood this. If you have understood, type yes. Bernoulli means how many outcomes? Type the answer. How many outcomes are possible in Bernoulli? Type the outcome fast, fast, fast. How many outcomes are possible in Bernoulli? Only 2. Correct. 2, 2, 2, 2, 2. Yeah, you are typing this. 2. Okay. How many trials are there in Bernoulli? Fast, fast. How many trials are there? There is only, correct. Yes, yes, yes. Type fast. It is one trial. So there is only one trial in Bernoulli. Got this point now? Bernoulli clear? Let's move on to binomial. In probability theory and statistics, binomial distributions. Here, what is binomial now? Here, it's very simple. When I repeat Bernoulli many times, what I get is binomial. Understand this sentence? When I repeat Bernoulli many times, I'll get binomial. Means what? For example, if I flip the coin once, it means it's Bernoulli. But if I flip the same coin 4 times, then it's binomial. Okay? So the binomial distribution with parameters n and p is a discrete probability distribution of number of successes in a sequence of n independent experiments, each asking yes/no question and each with its own Boolean valued outcome. Success with probability p or failure with q 1 minus p, right? Q equals to 1 minus p. A single success or failure experiment is also called as Bernoulli experiment, and a sequence of outcomes is called as Bernoulli process, or this Bernoulli process is also called as binomial distribution. Okay, so this is called as binomial distribution. So what did I say earlier? A single repetition of any flipping the coin is known as Bernoulli, and if you do it multiple times, it's called as binomial. Okay, so got this point? Binomial means what? Binomial means repetition of Bernoulli. Now one important point over here in binomial, I'll just give you in short. Okay, it means that when I repeat this Bernoulli many times, it means what? Each trial will be independent of each other. Means what? If I flip a coin, once I flip, I'll get head. Another time I flip, I may get tail or head. Suppose if I get head again, so 2 times I've got head. So if I flip the coin 3rd time, can you say with the guarantee that yes, 2 times it was head, the 3rd time also there will be head? No. Why? Because each trial is independent. That is what is said in binomial. In binomial, remember, each trial is independent because each trial is Bernoulli. Right? Got this point? So what is the formula for binomial? See this is the formula for binomial. We call this NCR, combination formula, NCR, okay? Or NCX we call it. So nx p raised to x q raised to n minus x. N is what? Number of trials. X is successes desired, means what is the success required, okay? That is x. P is probability of getting the success in one trial, and q is probability of getting failure in one trial. So remember, what are we doing over here? Each trial is giving you a probability of p and q, okay? Either it's a success or it's a failure in each trial. So p is for one trial, q is for one trial. X is the number of successes required. Means what? Suppose if I say, if I flip the coin 4 times, what is the probability I get a head? So getting the head is a success, and flipping the coin 4 times is this number of trials. Okay, so this is binomial. Now remember this formula of NCR. Okay, n factorial upon n minus r we call it, or x we call it, n minus x factorial and x factorial, p raised to x and q raised to n minus x, right? This is a formula for full binomial, and this is the formula only for NCR or NCX you will call it. Okay. Now third is Poisson. In probability theory and statistics, the Poisson distribution is a discrete probability distribution that expresses the probability of given number of events occurring at a fixed interval of time or space, if these events occur with a constant mean rate and independently of the time since the last event. Such a big definition. I know every one of you will say, oh, till the time I read the last part, I'll forget the first part. Don't remember the first part, don't remember the last part. Only one thing which I tell you, remember this. How to define whether the problem is Poisson? In Poisson distribution, remember the place or time will be constant. Place or time. Okay, I'll show you in the problems. Okay. So what is the formula? Remember this formula. There is no logic to this formula. You'll have to remember it. Lambda raised to x, e raised to minus lambda, the whole upon x factorial. X is what? Required number. Okay, required number. And lambda is what? Number of occurrences in that interval. Means this is, all these things would be given to you. And e is exponential, Euler's constant. This will be 2.71. This will be given to you in exam, or you'll have to remember 2.71. Okay, only remember 2 digits, 2.71. Okay. So now we'll move to the second part of our schedule, means these problems, numericals. Before that, see this 35 plus hours of ABM BFM, this selection batch which is going on now. Join as fast as you can, because 35 plus hours of ABM BFM, mocks and ebooks, last minute preparation, recorded videos are available 24/7. Solve unlimited doubts, June to July. Okay, this is a target exam, so join fast. I'll come to this, and you'll say the fees are heavy. See this. Use this code Y432. I'll show you at the end how to use this code so that you'll get huge discount. Huge means too huge. Okay. So let's solve the problem now. The coin is thrown 3 times. What is the probability that at least one head is obtained? See here, 3 times if I flip the coin. Okay. So this is what? Binomial, right? Because 1 time is Bernoulli, 3 times is binomial. So what is the way of getting this? Okay, there are 2 ways. I'll do this head, tail 3 times. Means when I flip the coin, I can get all the heads. I can get 2 head, 1 tail. Then all these possibilities. So this is one way of getting it. Okay. So in this way, how many are the outcomes? 1, 2, 3, 4, 5, 6, 7 and 8. 8 outcomes are possible, right? So total number of favorable is 8. Favorable cases is 7. At least one head I wanted. At least one head. So at least one head means, see this. This can be the possibility 1, 2, 3, 4, 5. This is also allowed. 6, 7. This is not allowed. TTT, because at least one head. I must get at least one H. So 7 are possible. So 7 upon 8. That is one way. Okay. But what is the other way? Using our formula also. P and Q, right? P is what? Head. That is 0.5. Q is what? Again tail, 0.5. So you can use this binomial formula also over here. Okay. So this is a simpler problem. That's why you can solve it directly using the sample space. Okay. Use the sample space. Total number of ways. Then what is the formula for probability? Always remember the formula for probability is required upon total. Required is what? 7. What is the total number of trials? That is 8. So 7 upon 8. Next one. Find the probability of getting numbered card when a card is drawn from a pack of 52 cards. Means numbered card means what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, what do we have over here? In cards, we have Joker, Queen, King, right? So these are not numbered cards. Okay, Ace is the numbered card. Remember this. Okay, so how many are there? So let's see. Total cards 52. Total cards 52. Numbered cards 2, 3, 4 is here. Ace is also not a numbered card. Okay. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many are there? 9. So 9 outcomes are there with numbered cards. Okay. And how many types of cards? 4 types of cards. So total 36. So 36 cards, if I get any of these 36 cards, it means that I'll get a numbered card. Means second, 2 of ace, 2 of heart, 2 of that diamond, anything. Okay. So out of this 36, any card if I get, I'll get a numbered card. So 36 upon what is the total? 52. Because total there are 52 cards. So 36 by 52, 9 by 13. That is the answer over here. There are 5 green and 7 red balls. 2 balls are selected one by one without replacement. Find the probability of that the first is green and second is red. Now remember, and means multiply, always in probability. Okay, and without replacement, I have not replaced it. So first is green. So green means what? 5. Required is, what is the formula for probability? Required upon total. 5 upon, this is 5 upon what are the total number of balls? 7 plus 5, 12. Okay. So 5 upon 12. This is first time of getting the green. But second is red. And means multiply. But at the second we are not replacing, without replacement. So how many are remaining? 11 only. So total is 11. Out of that 11 I must get red. So 7. Right? 7 are only red balls. So required upon total. And multiply them. 5 by 12 into 7 upon 11. Whatever calculations we get, you will get the answer is 35 by 132. Nothing gets cancelled. Okay. So this is the probability. Always remember the probability should be between 0 and 1. It should not be greater than 1. Okay. Now last one is the Poisson problem. Okay. If COVID cases of virus in Pune are occurring at a rate of 2 per hour, then what are the probabilities that 2 cases will occur in Pune in next hour? So remember, how do you define whether the problem is of Poisson? Something is constant, time or this period, okay, time or space basically. So what is constant over here? At rate of 2 per hour. So rate is constant, right? So immediately it must click to you that the problem is of Poisson. So Poisson, once you understand, then the formula. What is the formula for Poisson? Just now we saw it. What was this? This. Lambda raised to x, e raised to minus lambda upon x factorial, right? X is what? That is required. Lambda is what? Constant. So let's find this out. See this. 2 cases, that is a constant case which is required. Okay, so lambda means 2. And what is required? What are probabilities that 2 cases will occur in Pune? So this lambda is also 2 and the required part is also 2. That's why what we require is this third case. 2 raised to x, x is the required one. Okay, so 2 raised to 2 into e raised to minus 2, because e raised to minus x again, right? Say this, what minus lambda. So lambda raised to x, e raised to minus lambda upon x factorial. So use the same formula. Lambda raised to x, e raised to minus lambda upon x factorial. Here everything is 2. For ease, let's say this case is not 2, we'll say this case is let's say 1. Okay, we are having the answer for 1 also. So let's say the case is 1. One case occurs in Pune in next hour. So then use this formula. Lambda raised to x means 2 raised to 1, e raised to minus 2 minus lambda, the whole upon 1 factorial. So 2 raised to 1 is 2. 2.71, this e, say this given over here, raised to minus 2, do it with the calci. You can take this downwards, okay, so it becomes 2 raised to 1 upon, now look at this, e raised to 2, it becomes e raised to 2 into 1 factorial is 1, but e is what? 2.71, so 2.71 square, right? This becomes, got this point? So 2 upon 2.71 square, find this answer and you'll get this answer as 0.27, right? So probability of getting the new virus in the next hour, one virus, is 0.27. Similarly for 2 also, similarly for, what is the probability of getting 0 virus? If I make this as 0, then what? 2 raised to 0, e raised to minus 2, the whole upon 0 factorial. 0 factorial is always 1. So 2 raised to 0 is 1. So 2.71 raised to 2, right, below. So it becomes 0.135. This 2.71 comes down over here, okay. So it becomes 0.135. Solve it yourself. How many of you are solving? Let me see. Solve it yourself fast, everyone. Type the solve and get me the answer. Are you getting this 0.135? Fast, fast, fast. Yes. Are you getting this 0.135? Yeah. Many of you are getting it now. So this is the way to solve the Poisson problem. Now I'll come to this code. Okay, we are in the last part, ending part. So how to use this code? See this. I'll show you live. Okay. Go to Adda247 website, or if you are having the app, it's the best. Okay. In the app you will get extra points. So download that app as much as possible and then check all the sessions. Okay, I'll show you on the website because many of you don't have this app. Some of you, I expect everyone to download this app. So click on JAIIB CAIIB, click on this CAIIB. Once you click on CAIIB, you'll see the batches. Click on the selection batch. Once you click on this selection batch, you'll see the batch details. Read all the details over here. The same which I have told you, 35 plus hours of ABM, BFM, two-way interactive, mocks and ebooks, to 24/7 recorded videos. You can read it at your ease, okay? And this is the fees, 13,299. Now you'll say the fees is high. So click on offers, view offers, put this code. What is the code I told you? Y432. Put this code, click apply, see the fees now. See this, it is reduced to 3058, means 13,299 reduced to 3058. And the increment which you get is roughly 1300 after clearing CIB. 2 increments for clerical, 1 for that officer. But that is also roughly 1200 to 1300. So in 3 months, you'll recover everything. Whatever is left is yours throughout your life. So go for it. It's an investment for lifetime. Okay. I'll see you again tomorrow with another topic, and I'll see you in the live classes. Tomorrow join